Dear students, I hope you are well. Actually, in this COVID-19 situation and in this off-school session, I am trying to helping you with this channel. So try to be with us by subscribing this channel and also just like the Facebook page of this Smart Educare. You can find it in the Facebook also. I will give in the description. The channel's actually the Facebook page link in the description. I'll give it. So, but let's start today. Now we know that actually the energy, actually in the previous classes I have discussed about energy, but now we want the kinds of energy. Okay, so what is the kinds of energy? There is a many more kinds of energies, also the forms of energies, but the forms and kinds are not the similar. So actually we know that the maximum energy we use on the daily basis, those are mechanical energies. How we can move the board, or we can writing on the board, or we can move the duster, or we can drink and water, or even we are walking, or we are sitting, or just I am talking. Also the blood flowing in our body, it's also kind of mechanical energy. So those kinds of mechanical energy, basically two forms: the potential energy and the kinetic energy. Okay, so in today's classes I'm going to discuss you about the kinetic energy. So what is kinetic energy? So basically the kinetic energy is energy which is actually based upon motion, right? Which is based on motion. For motion we need kinetic energy. Without kinetic energy we cannot move anything. So for moving things we have to work, and for this work we need kinetic energy, because without energy we cannot do anything, right? So actually already I have stated that. I am telling you again that the most similar energies are mechanical energy, which is obtained due to position, shape or motion. Or that means actually which you can feel the touch, or we can see. That means the effect of force it can be seen or felt. It is actually kinetic energy, the mechanical energy. And basically mechanical energy has two types. Mechanical energy has two kinds. There's the kinetic energy and potential energy. So kinetic energy and potential energy, for today actually we only discuss about kinetic energy. So first one, let's move on with the definition. So what is the definition? Actually for the definition we need to explain. Okay, so that you can say the energy we use to push or pull so that we can move or stop an object. These kinds of energy is kinetic energy. Okay, I'm saying again that you can say the energy we use to push or pull so that we can move or stop any object. So that I have already I have told you about the moving object, right? For moving object we need energy, and for movement of the object we need kinetic energy. Without having any kinetic energy there will be no object that can be moved in this universe. Okay, so even we are breathing, flowing blood in our body, or we are doing anything, we are moving anything, so that's the kind of kinetic energy. So maybe we need a pure definition of kinetic energy. So just I think let's move on. So let's go to the definition. Okay, so the energy develops, actually for definition we can say that the energy the develops due to motion in a body is kinetic energy. Short technique actually, uh, and also it is appropriate for your 910 or SSC level, for your SSC exams. If you have any questions about SSC exam about that, what is kinetic energy, or what do you mean by kinetic energy, this is actually the definition you can write. I think for 1 marks it is enough, and if you will get want to get 2 marks, or for this number B questions, then you have to give through the explain about it. Why already I have told you some explanation about kinetic energy. Okay, so I think you will understand, or you are understanding now, that what I am trying to talk about, that about kinetic energy, what is kinetic energy and how we can use the kinetic energy. Actually using of kinetic energy we will discuss later for mathematical problems and other else's. So just thinking on that, now let's go to our actually the explanation. Just for the theoretical explanation it is not enough. We are actually we are speaking about physics, so we need some mathematical expression. So now we will go through the mathematical expression of kinetic energy. That means we need some mathematical formula to do some mathematical problems that will be given in our SSC exams or school exams. So I think we can just watch the board, then we can do some works, do some mathematical theory or proving the mathematical equations of kinetic energy. So I think everything about kinetic energy, actually the theoretical expression of kinetic energy is over. What do you think? Let me know about the comment section, or leave the comment, then I'll try to answer you. Also go to the Facebook page, like it, and also you can ask my ask to mine ask me also in the Facebook page. I will try to answer. Also, maybe I'll talk to you with the inbox and live chat with you any problems maybe you have. So I think we can go move on for now, and also we will go now through mathematical expression which is needed for us for mathematical expression or proving mathematical expression, or using mathematical expression to do mathematical problems. We will be given SSC exams or school exams. So let's start. Now maybe I can clean the board. What you say? Of course I will clean the board, then I will go to the next topic. Actually the next topic is mathematical proof or mathematical theories or mathematical formulas of kinetic energy. So let's clean the board. And also I think that you have already written the written definition, what I have written in the board. Even you have written on the notebook of yours. So first of all, let an object of mass m displaced by an amount s. So the displacement is s and the mass is m due to application of the force F. Think about that external force. It has to be an external force. Without external force, nothing can done. Actually, nothing can done. That means no works can done actually. So let an object of mass m displaced by an amount s. Okay. Also due to application of external force. Okay, application of external force. You can write force, but just remember it. It will be an external force. It cannot be an internal force. Okay, the force we have to think about the force. So the first letter of force is F. So we have to write the F on the sway. Okay, so the work. What will be the work? The work will be W equals Fs. I have already discussed it in the first class about this work, power, and energy chapters. So if you have any problem about that, go to the previous class, see it. Then you can see these classes. Maybe it will be better for your better understanding. So now we know the F equals ma, right? From the Newton's law of actually motion. I think all of the Newton's law you have remembered or you have memorized. But remember and memorize, those are different things. So we need some actual meaning of this between memorize and remembering. Those are the differences. You know it, I think. And for better understanding, we need actually to just to remember. Either maybe you will memorize them or not, I don't know. But just to memorize it is very risky for scientific systems or scientific subjects, especially for physics and chemistry. Maybe it will get you a better result on biology, but not for physics chemistry. It is very harmful for you. Just don't memorize. Okay, if you memorize it doesn't matter, but memorize, and also you have to understand what you are memorizing. Without memorizing understanding, memorizing, just memorizing it will be very harmful for the science students actually. Okay, so also in this creative system you need to understand anything actually, just not for science actually, because there is a creative questions which can be get sometimes get too much tougher for you. Not just tough, it will be tougher, much tough. So okay, so let's move on. Where we are, W equal to Fs. So we know the F equals ma, right? We know the F equals ma. So also I can throw you that I prefer the much equational sequences. Okay, the more equation we use, the more we can remember. Just think about it. That the first one I have written here, the W equals EF equals Fs. The second one, what we will get from the second one, what you will get, you can remember it, that the second one is that one. So if we are not getting the second equation or this one in second equation, that means we are mistaken, or we have mistaken in the early stages. So let's move on. So from the actually Newton's law of motion. Okay, so law of motion, second motion actually. Okay, so from the law of motion, not just the law, it is second law of motion, right? from F equals m, right? We got from the second law of motion in the actually fourth chapter. From the second law of motion, F equals ma. I am giving it a second equation so that maybe I won't forget that in the second equation we have written F equals ma. Okay, second equation we have written F equals ma, so I won't forget it. I think it will be help you to better understand, so better to be remember, not just memorize it, to remember it. Again, also I am using another equations here. If a moving object, think about that, if a moving object started from the rest, okay, so an object is now moving but it has started from the rest. So if it has started from the rest, that means it was previous, it has the previous velocity, that means u equals 0, right? From the rest means the previous velocity u equals 0, or the primary velocity u equals 0. So then just think about it, then u equals 0, right? So if u equals 0, that means the equation is v equals u plus at, will be v equals 0 plus at, because there is the mean of u equals 0. So I am just placing a 0 instead of u. I think you can understand it. So let's use the another law, or actually not law, formula, motion. Actually from the chapter motion we can get another formula actually, which is I can say that the s equals actually ut plus half at square, this one. Okay, so that's why I'm just marking the rest, okay, because the rest means u equals 0. Just when the rest is taking moving object, or an object has moved already, but when is it started from the rest, that means the primary velocity of this object has 0. So v equal to 0 plus at. 0 have no value, we know that, so v equals at. So this will be equation number 3. So now I am using another equation from another equation. That means we know that s equal to ut plus half at square, right? Okay, I'm writing, I think you are writing with me in your notebook, ut plus half at square. Thinking about that, if the same case from the upper section, so that if a moving object started from the rest, the rest means u equals 0, that means the whole product of u and t, 0 multiplied by t, will be 0, right? So there is no value of 0, so that we can just write it s equals half at square. Think about it, think about the ut, that is the whole product of ut equals 0. Okay, so we can just write half at square. Okay, we don't use there actually 0, because if I write here 0, then I have to go through the next line and then I will write the equals half at square. So maybe it can be equation number 4, right? Think about that. I am just using equations and equations just for remembering this, that which equation what we I am getting. From the third equation I have got v equals 80. From the fourth equation I have got half at square. So those equations has is remembering me that the equation and the getting things, or the getting equation. Okay, equation number and equation. Okay, so the third equation we got v equals 80. From the fourth equation we are getting half at square. So more equations you use, more help to remember those things. Okay, what I am showing you, I think it is helpful to you, and also from showing, just try to understand. Okay, try to understand. If you have any problem, just leave a comment below, then I'll try to answer you. Also you can chat with me, doesn't matter. So okay, so let's move on to the next, just for the next topic, or it hasn't finished yet, we have another part to finish. Okay, I think you have understood what I am trying to say. Okay, so what I am showing you, just I am saying again and again, from the rest, that means u equals 0, primary velocity is 0. Okay, from the rest, that means primary velocity or u equals 0. Also from the higher studies you won't use u actually, from the other things, but from this level it is okay. From this level it is okay, we are using u instead of primary velocity actually. And for the primary things we use another subscript or superscript systems from the in the higher studies, but in this studies, in this level, u is enough. So I think we can move on now, just try to understand. Okay, so So what I'm saying, I think is enough. What do you think? The 3 year third and fourth equation. Now maybe we will get fourth and fifth equation in this lecture. Let's clean it. Then we can get the rest of this topic. Not just rest of the topic, rest of this topic. We will prove it. That's the kinetic energy has some formulas. That means we can use some formulas to calculate kinetic energy from the given items. Okay, let's find here that we can discuss it. Let's clean it. So in that case, first of all, I'm going there. The work done. We need to calculate the work done. You need to calculate the work done. The what W equals Fs. Fs means MAS. I already told you from the equation number 2. Let's think about it. First one was the W equals MS. Second one was MAS, and the MA. Just think about it. What is the mean of S? S means half MA square AT square, maybe, right? Half MAT square. Okay. Half MAT square. Now we can get the half one is the first case. Then we can get the M. Then 2A. The product of A and A equals S square T square, and also from the now S square T square. We can get the S square T square equals to that means the V whole square, right? Because we got the third equation V equals AT. Okay, so the third equation we got V equals AT. That means instead of AT we can write V, and the superscript is square. That means it will be the same place. Then, so we can call it. This is the expression, actually expression or equation, whatever you call. Those are the mathematical expression or mathematical equation of kinetic energy. So there is another thing also. We know the law of motion, right? We know the law of motion. Do you know or not? I don't know that the law of motion is also a form of equation of kinetic energy. We can find kinetic energy equation from the law of motion. How can you solve it? Okay, how can you solve it? It will be my next topic. I'm not turning this video into a 1 hour or 1.5 hour. I'm trying to make a short video, actually. That's why I'm getting this short topic, not just both of kinds of energy, just one kind of energy, the kinetic energy. I will make 10 classes of potential energy in the next video, not this video. So I think it will be helpful for you, because we have other subjects, maybe just physics or chemistry. It will get you much more boredom than the other subjects. So I'm trying to make it just faster and the better and too much understandable for you. So let's get to the main topic, actually. Just not main topic, actually. It is a side topic of this main topic. So let's clean it. So actually from the law of motion we know that V square equal to U square plus 2as, right? Okay, I'm writing it in the board. I think you are writing it also in your notebook. So V square equal to U square plus 2as. Now if this equation is multiplied by half of m, think about it, half of m multiplied by, that means we have to multiply half of m with every single expression. Like V square, it will be half m V square, U square it will be half m U square, and 2as it will be half m into 2as, right? I am just trying to breaking it through. That means you can understand it well. So half m V square it will be the same, half m U square it will be the same, right? And there is a upper one, and the lower one 2 has been cut. So MAS, and also we know MAS. Think about it, half m U square, MAS. Think about it. What is MAS? MAS, that means F and S, right? And also Fs equals W. Okay, so from the law of motion we can get the equation of kinetic energy, the both kinetic energy. Think about that. The first one, half mv square, is the present kinetic energy of an object, and the The second one, half mu square, are the previous kinetic energy of an object. Somehow, if a 50 kg of man has worked something, that means he has some kinetic energy in the previous mode, like 10 minutes ago, but he worked 10 minutes, then his kinetic energy is changed. So what is his present kinetic energy? His present kinetic energy will be the total of the previous kinetic energy. That means he had like half mu square, and the work has he done. That means since 10 minutes he has worked something, and the addition or total of this work and his previous kinetic energy will be his present kinetic energy. So I think we can write about this statement. So we can say the present kinetic energy of any object will be the total of its previous kinetic energy and the work done. Okay, so I think everything is clear to you. And also for this kinetic energy thing, I've discussed everything actually which is needed for this SSC level, and it is enough. I think you don't want to know anything. If there is anything try my Facebook page or this channel's comment section. I'll try to help you. So I think that is enough for today. Good day and stay safe. Just try to stay safe. Thank you.